So next we will discuss the other counting techniques, the permutations and combinations. Now in permutation, elements are arranged in order. So we also call it ordered combinations. So objects may be repeated or may not be repeated. Now sometimes objects are also not so distinct. The symbolical expression of permutation is NPR. NPR. So when n is a positive integer, r is a whole number, and r is generally less than n. The meaning of NPR. So it means number of all possible arrangements or permutations of n and distinct objects taken r at a time without repetition. That means replacement is not there. So without repetition or without replacement, this is out of n objects, we are taking r objects at a time. So it is explained as NPR is equal to factorial n by factorial n minus r. So it is commonly used. Now if objects are repeated or replaced, then it will be n into and so on, or r times. This will be equal to n to the power r if it is replaced. Now in the set of n objects, if there are subsets of similar objects, sometimes it is seen that in the n objects in the space, there are some similar objects, and this will be considered as subsets. Then permutation of multisets are used. The concept of multisets are used in permutation. The permutation is given by factorial n by factorial p1, factorial p2, so on up to factorial pn. The fundamental counting principle is that if one operation can be performed in m ways, and there are n different ways in performing the operations, then the number of ways of performing the two operations together is m into n. It can be extended with number of operations. Suppose it's a multiset. So factorial n divided by factorial m1 into factorial m2, so on up to factorial mj. So m1, m2, that is mi, they are multisets. So this can be expressed as summation mi factorial divided by summation mi factorial. So this is the summation of the subsets. A frequently cited example is distinct anagrams of word Mississippi having multisets. So it is generally very easy to understand the concepts where multisets are there of similar objects. Suppose in the word Mississippi, so SS, there I, these are similar, then P, PP, these are similar objects. So this can be expressed as or represented as factorial 11. So there are 11 letters. This is factorial 11. And what are the subsets? M is 1. So it is 1 factorial. Then I, there are 4 i's, 1, 2, 3, 4. So 4 factorial. Then 4s, ss, ss, 4 factorial again, and pp, pp, so it is represented as factorial 11, factorial 1, factorial 4, and factorial 2. The only 2 p's are there. So this is equal to 3, 4, 6, 5. So 0 times. So homework. So similarly we can calculate for the word Calcutta. Now, in case of combination, order is not considered in selecting the process of items. Suppose 2 letters PQ. So one combination is PQ, others may be Q and P, but they're different permutation. They're different permutation, but combination is 1. This is considered as same combination. Similarly, AB and BA. Permutation is 2, but combination is 1. Then permutation is greater than combination. If we take 4 letters P, Q, R, S and take any 2 at a time, then permutation will be 4P2 is equal to 12. The general permutation formula is NPR is equal to factorial n by factorial n minus n. The combination formula is NCR. So it is equal to factorial n, then n minus r factorial and r factorial. So in case of permutation, r factorial is not there in denominator, but in combination r factorial is there. So it is used to choose r component out of total number of n component. If there are 4 letters P, Q, R, S taken 2 at a time, it will be 4C2 is equal to factorial 4 by factorial 4 minus 2 and factorial 2. Sorry. So this is equal to 4 into 3 into 2 into 1 by 2 into 1 and 2 into 1 is equal to 6 combinations. So in combination, same kind of things are to be sorted out. Now, in case of factorial, it is the product of all positive integers less than or equal to the positive integer itself. If n is a positive integer, its factorial is n. It is expressed as factorial n. This is equal to n into n minus 1 factorial. Let n is equal to 5. Suppose n is 5, then factorial 5 is equal to 5 into 4 into 3 into 2 into 1 is equal to 120. Now it can be used to calculate the number of ways to arrange n objects in a row. It is often used to select r objects from a set of n objects. It is used in many applications such as counting the number of possible outcomes in a probability experiment, then selecting a random sample, then designing experiments, analyzing data, etc. So with this, we have completed the main counting techniques. So thank you for watching and keep on watching. Please share. Thank you.